Hello everyone, this is Sakshi and I welcome you all to my editing platform, Way to Learn. So today we are going to just go through a quick revision of classical mechanics. So I hope this video will help you and regain what we have done in all my last videos of classical mechanics. So let us start. Uh, I had made videos on stability analysis, small oscillation, Poisson brackets, generating functions, phase space dynamics, Hamiltonian dynamics, Lagrangian dynamics, central force problems, and last one was special theory of relativity. So we are going to just revise all these topics one by one. I'm going to revise only the important points that you have to do or remember to solve a problem. So let us go for a quick revision. So in stability analysis, first step, that if you have a potential, you have to find the equilibrium points using dou v by dou x is equal to 0. Then you have to find if those equilibrium points are stable or unstable. That is, you have to take the second derivative and have to find if it's greater than 0 or lesser than 0. So if it's greater than 0, it's stable. If it's lesser than 0, it's unstable. So then we have to find the frequency using omega is equal to root k by m, where k here is our dou square v by dou x square. So it's very easy. So let us see our next topic, which is small oscillation. And here you have to write your t and v in matrix form, in their exact form. That is, you have to write, this is just one example. So you have to write, you have to make your t and v first in their exact form, that is half m x1 dot square plus half m x2 dot square, and then v to be half kx x1 square plus half kx2 square plus 2 kx1 x2, like that. So we have to get it in the exact form and then write in the matrix. Then we have to use the secular equation to find the angular frequency, which is the secular equation given as mod of v minus omega square t is equal to 0. So you have to note that the question contains the word normal. So you'll have the word like find the normal modes of frequency, right? So whenever you have these normal modes, you have to do using small oscillation. So let us see what are Poisson brackets. So Poisson brackets, like there are two methods. One can use the direct formula, which is given as here. There is a comma b will be summation dou a by dou qi dot dou b by dou pi minus dou a by dou pi dot dou b by dou qi. And one can also use the Jacobian identity, which is, sorry, it's Jacobian determinant. So which is given as dou a by dou q, dou a by dou p, dou b by dou q, and dou b by dou p. You have to just take the determinant and you're going to get the value. Okay, let's see generating functions. So we have these four generating functions. We have to always remember that these generating functions depend on which coordinate. So please keep a note on that and remember that. Okay, now we have to find the formula. How do we frame the formula? We can use this. Missing is equal to dou f by dou present. So, and also we have to remember the sign. That is, which is positive sign and which has the negative sign. So here is the answer. So for small q and capital P, we have negative signs, and for small p and capital Q, we have positive signs. So we will just see one quick example. So I say that F1 depends on Q, Q, and T. So the present is Q and small q and capital Q, missing is small p and capital P. So using this formula, I can write that missing is P and dou F1 by dou Q is present. And here the missing is capital P and dou F1 by dou Q is present, and it is negative sign because I have given here P to be negative. So I hope this is easy for you. So let us see phase space dynamics. We have to just learn how to draw the phase space diagram. So first we have to draw the Vx versus x graph using the equilibrium points and drawing a curve, Vx versus x curve. Okay, then we have to just draw Px versus x graph below. So for that we have to draw energy lines, that are these energy lines are nothing but the parallel lines that lie on the V of x graph. Okay, so next thing important is whenever v of x increases, that is the curve increases, p of x curve will decrease. And similarly, whenever it decreases, v of x decreases, we have to increase the p of x curve. Okay. And then this is one of the most important point, that is if the v of x curve is stable. We have seen in my first video in stability analysis what is stable, what is unstable. So in my phase space dynamics also we have seen what is stable or bounded motion. So you have to see that if you don't know. So here the curve of px versus x graph will be bounded wherever the vx curve is stable. So just check into my phase space dynamics video. And then one important note is that no two phase space curve intersect each other. So wherever you find any option having two phase space curves intersecting each other, then that option will be wrong. So for a conservative system, no two phase space curves intersect with each other. Okay, now let us go to Hamiltonian dynamics, where we know that h depends on q, t and t, and h is given as t plus v. And these are the important Hamilton's equation of motion. Remember these. And then this is one of the important where you can solve one problem easily using this. So if you have like a is a constant of motion, how do you find that a is a constant of motion? So the Poisson brackets of a and h will be 0. Only then a is said to be constant of motion. And then this is the other thing, the total time derivative of a is dA by dt is equal to Poisson brackets of a comma h plus dou a by dou t. It is similar to the same in quantum mechanics, but here we are going to use the Poisson brackets. So just remember these. Let us see what is Lagrangian dynamics, important points. Here Lagrangian depends on q, q dot and t, and L is given as t minus 3. And we know the canonical momentum is given as pq is equal to dou L by dou q dot, which is important. And then we have to know the Euler's Lagrangian equation or equation of motion, which is given as d by dt dou L by dou q dot minus dou L by dou q equal to 0. So, and this is one of the important formulae where we can find h when L is given or L when h is given. So here is a mistake. So it's nothing but this is h. Yeah. Okay. So whenever L is given, you can find h, or whenever h is given, you can find L. So I hope this is easy. And then important thing is that if L contains q dot, that is L contains only q dot, then it is said to be a cyclic coordinate. That is q dot, x dot, y dot, theta dot, anything. Then the corresponding momentum is conserved. So using this, you can find your canonical momentum. So if your Lagrangian contains only the dot terms, that is q dot derivative terms alone, then that coordinate is said to be cyclic coordinate. And if you find the corresponding momentum, that is the canonical momentum of that corresponding coordinate, that momentum will be conserved. So it is an important point to know. Okay, next we shall see what is central force, the important points. So force F of r is given as minus dou v by dou r. So whenever you have force given, you can just convert it into potential. And then effective potential is given as V effective is equal to L square by 2 mr square plus V of r. V of r here is your given potential in the question. And the condition for circular orbit is dou v effective by dou r equal to 0, which is an important thing. And using virial theorem, if f of r depends on r power n, okay, then the kinetic energy is related to potential energy as this. That is T is equal to n plus 1 by 2 into V. And then you have to just note this, the eccentricity value and the energy value for all these trajectories. So I hope this is easy for you to remember everything. Okay, so let us see the last topic, special theory of relativity. And here the Lorentz force Lorentz transformation formula is most important thing that you have to remember. You can see my last video where I have given everything about Lorentz transformation formula, and then the important formula is the differential form of the Lorentz transformation. So I had given a homework problem using this, so you have to solve that. Okay, so this is the Lorentz differential form, and then you have to learn this very well. Okay, and this is the velocity transformation of or relative velocity formula. So these are a few important formulas that we usually require to solve a problem. So from special theory of relativity, these are only few problems that I have provided over here. But when we solve the previous year question or the previous year like paper, when we are going to solve all those, I'll be solving all the questions and I'm going to tell you all the formulas required to solve a particular question. So you can have your formula notebook, you can write all your formulas in there, and then whenever we solve a problem, if you have some new formula in that, you can just copy that in your formula notebook so that it will be easy for you to revise every time. So this is a quick revision on classical mechanics. And yes, the next subject that I'm going to deal with is mathematical physics. So hope you like this video. So thank you for watching till the end. Please do not forget to like my videos, share my videos, subscribe my channel, and also do not forget to hit the bell. So because we are going to have exams like maybe in July or later, because just postponing, we don't know when it is going to happen. So I'm going to just prepare for that, and I'm going to help you prepare for that. So stay tuned for more videos for our exams. And if you like this video, please share it with your friends so that they can also learn it. So thank you. See you tomorrow. Bye bye.